What are transmitted forces? Forces that are transmitted from one point to another. For example, two objects connected by an ideal string. Object 1 rests on a frictionless table. Object 2 is supported by the string. The ideal string is moving over a pulley, changing the force's direction. You can determine the acceleration of the system of the objects in which the force producing the acceleration is applied to the mass of the system. To determine acceleration mathematically, you need to consider all of the forces acting on each object separately. Make a free body diagram for each system. Assume where the unknown acceleration is directed to. And remember, magnitudes are always positive. To determine the acceleration experimentally, you need to find the change in velocity in a measured time interval. The recording timer used in this lab will show the change in motion of the cart as it accelerates up the incline. After you determine the first dot and its velocity as 0 meters per second, you need to find instantaneous velocity. The easiest method to do this is finding the average velocity between two close points. After choosing your points, you will need to divide the distance by that time interval. When comparing experimental and mathematical value, you will find the difference because of friction, human error, and equipment precision and accuracy. Performing the laboratory. First, determine the cart's mass. Set up the inclined plane. Set the angle of the plane at 20 degrees above the horizontal. Secure the recording timer to avoid movement. Tie a string to the mass. Cut the timing tapes into fit length. Place the string, linked to the hanging mass, in front of the cart. Start the timer. Release the string that holds the cart back. Repeat the steps, changing the hanging mass for trial 2 and only the cart's mass for trial 3.